Homothetic functions. So yesterday also we were talking about homothetic functions. Now we'll take the discussion further for the homothetic preferences again. So the first property I just want to take, and you also have to remember about the way we have defined homothetic function yesterday, right, in the earlier recording. And from there, we'll move one step forward to say this. That is, homogeneous functions are homothetic. Homogeneous functions are homothetic. So if the function is homogeneous, then that function would be homothetic. But there are many homothetic functions which are not homogeneous, right? So let me prove the first one first. That is, if u lambda x is equal to lambda to the power k u of x. So this is a homogeneous function. Since lambda is completely factored out, this is a homogeneous function. And what is the degree of homogeneity here? K. And we want to show. Then preferences are homothetic. Then preferences are homothetic. Well, a function u is homogeneous of degree k if u of lambda x is equal to lambda to the power k u of x, right? Now suppose ux is greater than equal to uy. So there are two bundles, x and y, and the utility which you get from x is more than or greater than equal to the utility which you get from y. So, and u is homogeneous of degree k. So u of lambda x could be written as lambda k u to the power x, right? And so, okay, so beta, u of x was greater than uy, right? So if you multiply both the sides of ux and both the sides of ux and uy here with lambda to the power k, it doesn't change anything. You with me? So what I'm trying to say is this: u of x is greater than equal to u of y. You're writing u of lambda x as lambda to the power k u of x. Why? Because u is the homogeneous function of degree k. And since ux is greater than equal to uy, so lambda to the power k ux is also greater than equal to lambda to the power k u of y. But the moment you write lambda to the power k u of y, you can also write this as this: u of lambda y. You've proved your point. You've proved your point, right? So you're saying if ux is greater than equal to uy, then u of lambda x is greater than equal to u of lambda y. That's what you have said here. U of x naught is greater than equal to u of x1. That's what you have said here, beta, yesterday. U of x naught is greater than equal to u of x1. Then u of theta x naught is also greater than equal to u of theta x1. That's what you said yesterday here, right? Okay, so what you have proved, if the function is homogeneous, that function is homothetic. Let us look at one example. Let us look at one example. So you have u of x is equal to a1 x1 to the power alpha plus a2 x2 to the power alpha, and alpha is lying between 0 to 1, right? But you take up, I mean, you just increase x1 and x2 both by lambda. In place of x2 you have, this is x1 beta, x2, like this. So what I can do, it becomes a1 lambda to the power alpha x1 to the power alpha plus a2 lambda to the power alpha x2 to the power alpha. I'll take up lambda to the power alpha common. So I have x1 to the power alpha e2 x to the power alpha. So what you have shown is, beta, this is nothing but ux. So u of lambda x is equal to lambda to the power alpha u of x. So lambda is completely factored out, and it is factored out with the degree of alpha. So this u is homogeneous of degree alpha. So u, therefore utility function is homogeneous of degree alpha. And since it is homogeneous, you just said if the function is homogeneous, it is homothetic, and therefore homothetic. Can I also write it in this way? Can I define small ux as this capital Ux to the power 1 upon alpha? I can do that. And then I write as small u lambda x would be capital U lambda x to the power 1 upon alpha. So since this is homogeneous, so I can write it in which fashion? So it becomes what? Your lambda to the power alpha, right? Capital Ux to the power 1 upon alpha. I can write like this, right? I can write like this, and this thing becomes what then? This lambda to the power alpha into 1 upon alpha would become just lambda to the power 1. Lambda to the power 1, and this is capital Ux to the power 1 upon alpha. Well, capital Ux to the power 1 upon alpha is what? Small ux. So what you are trying to say that small u lambda x is equal to lambda to the power 1 small ux. So what you have done is that these preferences, they could be represented by the function which is homogeneous of degree 1, right? So thus these preferences can be represented by a function which is homogeneous of degree 1, which is homogeneous of degree 1, right? So you can just turn around the definition just a little bit. So you can write this. You can probably write this. That is, a preference relation R is said to be homothetic if and only if it can be represented by a utility function that is homogeneous of degree 1, right? So what you're saying is that the homothetic preferences, they could be represented by the utility function such that u of lambda x is equal to lambda ux with lambda greater than 0. So that would make it homogeneous of degree 1. Now note that the definition is not saying that for every utility function that represents these preferences, such utility function must be homogeneous of degree 1. No. The definition is not saying that. It is saying that there must be at least one utility function. There must be at least one utility function that represent these preferences, and it is homogeneous of degree 1, right? So there's a difference between the two things. Let me write this point also. So what you're saying is this, that homothetic preferences can be represented by a utility function such as u of alpha x is equal to alpha u of x with alpha greater than 0, right? So note that the definition does not say that every utility function that represents the preferences must be homogeneous of degree 1. No. It is not saying that. It is only saying that there must be at least one utility function that represents these preferences and is homogeneous of degree 1, right? So I think I need to talk a little bit more about this point. So I'll bring a little proof tomorrow with this. But I just want to do one more thing today, right? So I might have to talk a little bit more about homothetic preferences, and I want to talk in a little detail about this homogeneous of degree 1 point. So I'll bring one small definition also tomorrow. Now one example which I want to give is that all homothetic functions, they are not homogeneous. So that's not necessary that all homothetic functions are homogeneous. No, that's not necessary at all. But before than that, I'll tell you an easy way to check the homothetic functions. So what you can probably do is just in case if you have the continuous function and you can find out the MRS. So if that MRS is homogeneous of degree 0, that function is a homothetic function then. So let me just give you an example. Let me just write the point first. So how do you check whether the function is homogeneous or not? Again, for this also you have a proof, but I want to give an example first and then I'll give you the proof tomorrow. So if the slope of indifference curve, and what is the slope of indifference curve? Marginal rate of substitution. Depends only on the ratio of the variables that enter the utility function and not their absolute levels. Right? Then utility function is homothetic. I'm not giving a proof today. I'm just giving you an example for this point. So suppose you have the function u is equal to xy, x to the power alpha, y to the power 1 minus alpha. You want to find out the MRS. That is del u by del x upon del u by del y. So that is alpha x to the power alpha minus 1, y to the power 1 minus alpha upon 1 minus alpha x to the power alpha, y to the power 1 minus alpha minus 1, that is minus alpha. Right. So if you just write this, it becomes alpha upon 1 minus alpha, alpha upon 1 minus alpha, and this y when it goes up, so it becomes y to the power 1 minus alpha plus alpha, so it will be just y, and this x to the power alpha minus 1 when it comes down, it becomes x to the power alpha minus alpha plus 1, so it becomes x. So this is what your MRS is. And as you guys could see, it is dependent upon x and y. Well, MRS this MRS which you have just found out is homogeneous of degree 0 in x and y. How? So what you're trying to say is this. Your MRS lambda x lambda y would be what? Alpha upon 1 minus alpha lambda y upon lambda x. So it is alpha upon 1 minus alpha y upon x beta. That is the same thing as MRS xy. So you can also write this as lambda to the power 0 MRS xy. No? So homogeneity of the degrees, homogeneity of the MRS of the homothetic functions by degree 0, that's a general property of the homothetic functions. So it follows from the fact that homothetic functions are homogeneous of degree 1. So their partial derivative is homogeneous of degree 0, right? So that's an easy way to check. So if your MRS is like this, it is only dependent upon the ratio, not on the absolute values. It is homogeneous of degree 0 in x and y. Its MRS is homogeneous of degree 0 in x and y. Yes, it is a homothetic function, right? So, and then I'll end this with this point. All homogeneous functions are homothetic, but not all homothetic functions are homogeneous, right? Not all. Not all homothetic functions are homogeneous. For example, you have u is equal to xy. That's a homogeneous function, and that is also a homothetic function because its MRS is y by x and it is only dependent upon the ratio, and that is its MRS would also be homogeneous of degree 0 in x and y. One thing is that. See, this is, let's say, u1, so it is u2. Okay. Is this homogeneous? This is not homogeneous. So you would not be able to factor out lambda completely. So for example, lambda x, lambda y, so it is lambda square xy plus 1. So you're not able to factor out lambda completely, so it is not a homogeneous function. It is not a homogeneous function. But if you look at the MRS for this, so what is del u by del x? That is del u2 by del x is y. Del u2 by del y is x. Now it's simple. This you know already. So, and guys, this is the function of x and y. So MRS lambda x lambda y would be what? Lambda y upon lambda x. So it is what? Lambda cancels out. It is just y by x. But that is what? Lambda to the power 0 MRS xy beta. So it is what? Its MRS is homogeneous of degree 0 in x and y, right? It is a homothetic function. This guy is a homothetic function. So although it is not a homogeneous function, but a homothetic function. So all homogeneous are homothetic, but not all homothetic are homogeneous, right? So this is one thing which I want to do. I'll still have more to talk about homothetic functions. So I'll talk about that. And I will also have to talk about that degree 1 wala thing. So I'll bring out one proof, maybe tomorrow, maybe day after tomorrow. I'll do that. Thank you, beta.